So I'm going to talk about the fermentation unit operation. So basically what it is, in a nutshell, you guys know. So you're just reducing the oxygen content and cutting off all oxygen to the yeast. And what that does is it converts the simple sugars, the glucose, into ethanol without the oxygen. So what we're using is pre-inoculated brewer's yeast, traditional way to make beer and wine and such with just yeast. And then you know that when the process is complete, because the specific gravity using hydrometer doesn't change, it starts to just stay at the same buoyancy level. Um, so with that, the actual unit operation, so the primary variables that we're looking at here are time, temperature, and then initial sugar concentration. There's other things that play a factor, a lot of cofactors with the enzymatics and reactions, magnesium and nitrogen and oxygen and stuff like that. But so basically time, if you let it go out for a further longer period of time, the fermentation will go to a more complete reaction. And then the initial sugar concentration, that's just what the yeast is living off of. So if you have a very low sugar concentration, the yeast won't be able to live long and won't convert that sugar into ethanol. Think of the ethanol being a direct product of the sugar concentration. And finally, the temperature. What we're doing for our experiment is just room temperature, but as you can see in the bottom part of the slide, temperature fluctuations can change the ethanol concentration at the end of it. So what the yeast primarily look for, and that changes, all of these things change with the different type of strain that you're using, and even if you're using different bacteria or yeast, for each fermentation reaction is totally different depending on the organism in use. Everyone, so I'm going to continue talking about the experimentation side of things. So what we did is on Tuesday, 12th the 4th, we began the whole experiment with the Soy IPA. So we started with blending the barley, the malted grain, for 20 seconds in little batches and just a blender that Okos has, and then weighing out the masses and recording those. And then after that, we started the mashing process. So we added in the water, and then we did it like the heating series for the drying. Still drying design. So if you remember that, you increased it, held it for a while, increased it, held it for a while. And with that, it was difficult to actually do in the lab. We were just doing it on a stove top, so there were times when we would be at with the set points being 50, 65, and 80. There would be times when we would shoot to 55 and then have to go back down, and then 67 and go back down. So that would definitely play a role in the mass balances and energy balances that we were looking for. But that's something to keep in mind for later experimentation and how to control that better. So after the mashing process, we filtered it with cheesecloth and sieves that Professor Oko said. So there's still a lot of residue left in the wort currently, which is okay for now, which will be fermented. And but those cheesecloths and sieves they were able to get out the big bulk of the barley, but all that stuff that got blended out into superfine particles still was able to go through the filtration methods. And after that, we boiled the wort with orange peel and hops for 60 minutes to impart flavor. And then finally, we mixed the final wort with the soy whey isolate, yeast, sugar, and a bit more water, and put it in the carboy to ferment for 5 days. So we cap that off. It looks like there's just tin foil on it right now, but there it is. There's a rubber stopper in there. So yeah, we're gonna measure the temperature each of those days, and then at the end of it, we're going to look for a better filtration method. We talk about that in the next slide, but we'll probably just use a siphon after gravity filtration lets that all settle down. So yeah, that was the experiment side. If that 5-gallon carboy was all liquid, we would get about 53 gallons of liquid, but we won't. So that's about not 53 gallons, 53 beer bottles full of beer. So if you want a beer, come ask.